Hi, I welcome you all for this session. In this session, we are going to discuss about peripherals of LPC 2148. So this processor is designed by Philips Semiconductor, and it is a 16-bit or 32-bit microcontroller based on ARM7 processor family. It has the ROM face read-only access, read-only memory, 512 KB, and a random access memory, 40 KB. It has two 10-bit analog to digital converter with 14 channels, 14 analog inputs, and one 10-bit DAC digital to analog converter, and two timers, 32-bit timers, timer T0 and T1 corresponding to port 0 and port 1. One watchdog timer is available. And you have two I2C bus, two UART 0 and 1 corresponding to port 0 and port 1, two SPI and one USB port to download the code from PC to the processor. So as I said, it has a SRAM, random access memory. It's used for storing data or code. It can be accessed by 8-bit, 16-bit or 32-bit. And flash program memory. It's used for data storage as well as code storage. It's flash memory, on-chip flash memory facilities available. Next one is digital to analog converter, D2A. So the maximum voltages are called as V reference. So in this converter, power down mode and buffered output facility is also available. Buffer means we are using flip-flops, delay flip-flops to store the data. And also power down mode to reduce the power consumption. The next one is analog to digital converter. We have two ADC0 and ADC1 correspond to the port. So 10-bit analog input to digital output can be done. The range from 0 volt to V reference. And UART 0 and 1. So once the baud rate is generated, this UART can access serial communicator used to transmit 16-byte both transmit and receiving from PC to the outer peripherals through serial communication. UART is nothing but universal asynchronous receiver and transmitter. Next one is I2C, bidirectional multi-master bus facility. It can control two or more buses which are connected to it. As seen in the diagram, see here, this I2C protocol will control one master would be there and another slaves would be there. So data can be transferred from master to slave and also from slave to master bidirectional. Similarly, clock synchronization is also available for handshake mechanism. Timers, timer 0 and timer 1, 32-bit capture channels are available. So this peripheral clock signals are reduced by pre-scale counter, so the timing pulses can be generated for every second. If you see in the timer video, we have a small calculation to generate delay timing signals, and that is used in LED switch on and off, LED on and off program. So So timing signals can be generated once the value in the match register and the timer control are equal. So it can reset the timer or stop the timer or generate some interrupt signals. So if you in that timer PPT timer video, if you see, you can see the operation of the timer block diagrams, and small program is there for understanding how it operates. Next one is watchdog timer. It's very important one. If anything goes wrong, uh, if the system got hang, it has to reset. So the watchdog timer will monitor the processor work. If anything goes wrong or anything hang, then this watchdog timer come into picture to reset the microcontroller or the ARM processor. Next one is real-time clock. It is designed to set the counters for measuring the hold time when the controller is in operating mode or idle mode. It works with little power, low power. Even a battery can be used to operate this real-time clock. Next one is phase lock loop, PLL. PLL is used in the prescaler so that the frequency can be changed for every second. The pulses can be generated depend on the frequency available. So that's all about this peripheral. So we have seen the peripheral name and how it functions, how many are available. In detail, we will see about UART timer PWM generation of signals in the upcoming videos. Thank you.